Okay, so now we're going to talk about solving inequalities. So to do that, we're going to use the inverse operations to isolate the variable just as if we were solving an equation using that multiplication and division. So then we have the inverse operation of multiplication is division. You already know this. The inverse operation of multiplication is division. So the inverse operation of division is multiplication. All right, so numbers 4 and 5, this was the new part that we talked about last time. So when graphing an inequality where the number is a solution, we are going to use a closed circle. So that means whenever you see the greater than or equal to, or the less than or equal to, we are going to have a circle that is filled in. So that's what it means to be a closed circle. So because of the equal to portion, we're saying that number could be a solution, so that's why it's filled in. So when graphing an inequality where the number is not a solution, we use an open circle. And so you would see the greater than or less than symbol, and then that would be just a circle that is not filled in. And that's how we would graph it. Well, then you can probably figure out what the next one is. That is the multiplication property of inequality. So the multiplication property of inequality. The multiplication property of inequality says that when we multiply each side of an inequality by the same positive number, this is super important, it only works for positives, the inequality is going to remain true. So if we multiply both sides of the inequality by 2, it'll work. If we multiply both by positive 10, it'll work. So then I bet you can figure out the next one. So that would be the division property of inequality. The division property of inequality. So the division property of inequality says the same thing, except that you're dividing. So you can divide each side of an inequality by the same positive number, and it'll remain a true statement. Notice that these have to be positives. We're not going to talk about the case with negatives because you're going to do that whenever you get into 7th grade. Okay, so then number 8. To check your inequality solution set, we're going to choose any number that is in the shaded portion. So we're going to choose any number that is shaded in. So remember when we graph, we shade to the left or to the right, and we're going to choose any number on that shaded side. And then we are going to evaluate. And solve the inequality with that number to make sure that the inequality is true. Because if we get a false statement, then we know that we shaded the wrong direction. Okay, so let's solve and graph each inequality, and then we're going to check our answer. Okay, so we have 2g is less than or equal to 10. Well, what operation is happening between 2 and g? Multiplication. So the inverse of multiplication is division. So we're going to divide both sides by 2. Well, 2 divided by 2 is 1. So we're left with 1g, or just g. Then less than or equal to, well, 10 divided by 2 is 5. Okay, so we're saying g is less than or equal to 5. Are we going to have an open or a closed circle? It is going to be closed. And why is it closed? Because we have the equal to portion of our inequality. So we're going to come over here to the number 5. We're going to have a circle that is filled in. Now we need to figure out if we're shading left or right. So we're seeing g has to be less than or equal to 5. So what numbers are smaller than 5? 4, 3, 2, 1, 0, -1, all those. So all the numbers to the left. And then don't forget to put that big arrow because it continues on to negative infinity. Okay, so now to check, all we do is choose any number on that shaded side and we're going to plug it into the original inequality. So let's choose like the number 3. So 2 times 3, we're checking to see, is this greater than or equal to 10? Because remember, we're going back to this original one right here. Well, 2 times 3 is 6. Is 6 less than or equal to 10? Yep, so we know we shaded the correct direction. Okay, on our next one, h divided by 3 is greater than 1. Let's rewrite this without the division symbol. So we're going to write it as a fraction. So we're going to do h over 3 greater than 1. Well, what's the inverse operation of division? Multiplication. You could also think about the multiplicative inverse, or that reciprocal, which 1/3 is a 3 over 1. So that's why we're multiplying by 3. And then multiply by 3 over here. So we can see our 3's cancel, those 1's cancel, so we're left with a single h. And then greater than, well, 1 times 3 is 3. So our inequality is h is greater than 3. Is this going to be open or closed? Right, it's going to be open. It's open this time because we do not have the equal to, so h cannot actually be the number 3. It can be close to it, but it cannot actually equal 3. We're saying h is greater than 3, so what numbers are bigger than 3? All the numbers to the right. All right, well now let's choose any number. Remember, we're going to be dividing it by 3. So let's choose a number that we know is divisible by 3 that's bigger than 3. So we could do 6, we could do 12, lots of different options. So let's just plug in 6. So we have 6 divided by 3. Checking to see, is this greater than 1? Well, 6 divided by 3 is 2. Is 2 greater than 1? Yep, so we know we shaded in the correct direction. All right, let's flip over and finish. Okay, so we're gonna solve and graph. Notice that on these here, we don't have the numbers on the number line, and that's okay. So we're multiplying 8 times g, so the inverse operation of multiplication is division. So we're gonna divide both sides by 8. Well, 8 divided by 8 is 1, so we're left with 1g, which is greater than or equal to, well, 72 divided by 8 is 9. So we have g is greater than or equal to 9. Is this going to be open or closed? Closed, because we have the equal to on our symbol. All right, so if it gives us a number line without any numbers, we can choose the numbers to put on there. So let's think smarter, not work harder. So let's just put 9 in the middle, and then we could count by 2's after that. We could count by 3's. We could just count by 1's. So in this case, I'll count by 3. So we'll have 9, then 12, and 15. Going back, we would have 6, and then 3. All right, so at the number 9, we're going to have a closed circle. So it is a circle that is filled in. Well, now are we shading to the right or to the left? Well, g has to be greater than or equal to 9. So all the numbers bigger than 9 would be to the right. So we're going to shade all the numbers to the right. Well, now let's choose a number to plug in that's in the shaded side. So we could choose 10, 11, 12, 13, 13.5, whatever we want, we could plug in. So let's just do the number 10. So let's check. 8 times 10, is this greater than or equal to 72? Well, what's 8 times 10? It's 80. Is 80 greater than or equal to 72? Yep. So we know we did it right. All right, number 2. Let's write it in standard form. So that would be w over 4 is greater than 12. You'll most commonly see these in fraction form instead of with the division symbol. Well, the inverse operation of division is multiplication. So we're going to multiply both sides by 4. You can see those 4's cancel out to be 1. So we're left with one single w is greater than, well, 12 times 4, 48. So w is greater than 48. Are we going to have an open or a closed circle? Open, because we don't have the equal to. So I'm going to put 48 in the middle, and then I'm just going to count by 1's this time. So I'm going to do 49, and then 50, and then to the left we have 47 and 46. Well, at the number 48, I have an open circle. Well, now I need to figure out if I'm shading to the left or to the right. W has to be greater than 48. So what numbers are bigger than 48? Well, that would be 49, 50, 51, 52. So all the numbers to the right. Now let's choose any number to plug in the shaded side. So think about in this original one, I'm gonna have to divide it by 4. So let's choose a number that's divisible by 4. We could do the number 60, that would work. So let's do 60 divided by 4. We're checking to see, is it greater than 12? Well, let's do some division here and figure out what 60 divided by 4 is. 4 goes into 6 once, and then we have a remainder of 2, drop our 0. 4 goes into 25 times, and so we have a remainder of 0. So we have 15 is greater than 12. Is that a true statement? Yes, it is. So we know that we shaded the correct direction. All right, number 3. So we have 12 is greater than 4x. So we have multiplication happening. So the inverse multiplication is division. So let's divide both sides by 4. 12 divided by 4 is 3. So we have 3 is greater than, well, 4 over 4 is 1. So we're left with one single x. So 3 is greater than x. So I'm going to put 3 on my number line, and then I'm just going to count by ones again. You can count by any number you want as long as you're consistent. Is this going to be open or closed? Open, because we don't have the equal to. 3 is not actually a solution. So at the number 3, we have an open circle. Well, now, am I going to shade left or right? I want you to think about it. So 3 has to be greater or bigger than x. Well, I could rewrite this inequality as x is less than 3. And remember that you have to keep your symbol on the correct direction. So like the bigger end had the 3 with it. So whenever I flip it, I have to make sure that the 3 also has the greater than side with it. So now we can read this as x is less than 3. So in other words, x has to be smaller than 3. So all the numbers to the left of 3 are smaller. So you have to be careful whenever that variable is on the other side, and so that you don't get confused on which direction to shade. Let's choose a number to plug in. Let's choose the number 1. We can do that. So let's check. Is 12 greater than 4 times 1? Well, 4 times 1 is 4. So 12 is greater than 4. So we are good to go. We shaded the correct way. And lastly, number 4, let's write this in standard form. So getting rid of that division symbol, we would write it as a fraction. So we have d over 6 is less than or equal to 66. The inverse operation of division is multiplication. So we're going to multiply by 6 on both sides. We can see that those 6's cancel, so we're left with one single d, and then less than or equal to, well, now 66 times 6. If you do a little bit of scratch work, so 6 times 6 is 36, carry the 3. 6 times 6 is 36 plus 3 would be 39. So d has to be less than or equal to 396. Is this going to have an open or a closed circle? It has to be closed because we have the equal to. So on my number line, I'm going to put 396, and then I'm just going to count by ones again. Remember, you can count by whatever number as long as you're consistent, and put it in the correct order. So at 396, I have a closed circle, so a circle that is filled in. Now am I going to shade left or right? We say that d has to be less than or equal to 396. So that means it has to be smaller than 396, so we shade to the left. Okay, well now let's choose any number in the shaded in portion to check. Remember that we're gonna have to divide it by 6. So let's choose a number that's divisible by 6. Well, 36 would be on that left-hand side, so let's do that. So 36 divided by 6, we're checking to see, is this less than or equal to 66? Well, 36 divided by 6 is 6, so we have 6 is less than or equal to 66, and that is a true statement, so we know we shaded the correct way.